We're agnostic to what language models we're using. We are constantly testing various language models to see how well they perform, and which ones produce the results we're looking for them to produce. If you ask me what language model, I'd have to go back to some of our scientists to give you a catalog of the ones they've used most recently. A good analogy for anybody who thinks about how these things are being trained inside of our physics truth, training gym is you can kind of go back to these articles about Go, when Go started beating the best players in the world. And you could, in the morning, you would essentially give the artificial intelligence the rules of how Go functions and the objective of the game of Go. And quote unquote, in the morning, you would give it the rules and the objectives. That's parallel to the physics true portion of the gym. So AI doesn't have to learn Go, it has that built in, so it doesn't have to learn physics. And then you essentially, with Go, you have the AI play against itself over and over and over and over again, where it's using typically reinforcement learning, where it's being reinforced for winning and not being reinforced for losing. Until you reach a point where you then take out one of the sides and you say, okay, I'm just going to have a human being play against you and see how you fare. And artificial intelligence can get very good at Go very, very quickly. I am dramatically oversimplifying what we do with artificial intelligence, but imagine a situation where you're essentially, the artificial intelligence doesn't have to learn the physics, and you're using using some type of learning methodology with that artificial intelligence to train it to, in this case, look for anomalies in a constellation.